people in the audience, feel free to unmute yourself and ask questions. I've given all the attendees permission to talk, or if you want, you can put questions in chat and Hanming will respond to those. And as last time, let's give the presenter the first and last 5 minutes. And on that note, it's all yours. Take it away. You should share your screen and start the presentation.
Thank you for joining the session. So this project is joined with my advisor, Hanming Fang at University of Pennsylvania. And my name is Xincheng. And the title of the project is Golden Ages, A Tale of Two Labor Markets. And I'm gonna be clear about what we mean by golden ages in a few seconds. So we start by describing a few facts. The age earnings profiles is a familiar object in economics and widely documented. So here in the graphs, I plot annual real earnings in the y-axis and ages in the x-axis. Each curve represents a group of adjacent years, and the left panel is before 2000 and the right panel is afterwards. So the cross-sectional age earnings profiles for the US male workers exhibits a hump shape, meaning that earnings are low for young workers and it's increasing with age, and at some point it reaches the maximum and then declines. And you can see that the shapes are pretty much the same over the past 30 years or so. And we will call this peak age, so the age group that achieves the maximum earnings among a cross-section as the golden age. So in the US, the golden age is around 45 to 50 years old, and it's roughly constant during the past 30 years. A second observation of this graph is that not only the shapes are relatively constant, but also the levels did not change much in the US. So the curves shift upwards a little bit, but not so much, reflecting the wage growth stagnation in the US. Now we replicate the same exercise for China. So it exhibits a completely different picture here. So first of all, it's striking that the curves shift upwards quite a lot. This reflects the dramatic increase and actually continuously increasing wages in China. Second, the shapes are also a little bit weird for China. So in the late 80s, it's kind of standard with the hump shape, but gradually the age earnings profiles become a little bit flat, and in around 2010, the peak age is something like 35 years old. And this is something not very common in the evidence we have so far. So this is kind of some motivating facts we are gonna explore in this presentation. And before that, I'm gonna repeat the snapshots here with some dynamic graphs. So for the US, we can see that the age earnings profiles are pretty, sorry.
Oh, can I ask you a quick question, which is,
yes,
how much of it is just the Cultural Revolution cohort? Like you're showing us how the age profiles change over time. How much of that is just reflecting that the Cultural Revolution cohort, people who were born, like say, like in the early 50s to early 60s, that they just have lower human capital, so they just do worse off, and that's what's pushing down the earnings of the elderly in the more recent years, and also pushing down the earnings of the younger guys and the middle age guys in the earlier years.
Let me jump to this graph to answer your question. So for example, let's just look at say, the cohort born in the 1950s or the 1940s, so somewhere between here. And this is their age profile across over the life cycle. So first of all, this is a different picture than what I plotted before, but this is for a given cohort. So the blue line and the red line, they are approximately the cohort you are mentioning, the Cultural Revolution cohort. So indeed, the levels are relatively lower, but it's not particularly extremely low or extremely different from other cohorts, but indeed they exhibit a relatively low growth pattern. But I'm gonna come back to this cohort.
It's not the yeah, so we can wait, but I guess to me it's not just that the levels are lower, right? What I see is like parallel shifts of lower levels as you go across, and then once you hit the Cultural Revolution cohort, the slopes actually flatten. And that's sort of like the relevant thing for explaining the age profiles.
Yes,
but
so
I can wait.
Yeah, so what I'm saying is I think we do not identify anything peculiar about that particular cohort, because overall we do observe an increase in slope across cohorts. But I will come back to the cohort thing later. Okay, so let me continue this dynamic
Hey, Xincheng,
graph.
can I ask a question regarding the data? So we're looking at US versus China. So are the samples comparable? So I'm not sure like what's the data source you use for the two countries.
So for the US, I'm using the CPS, the current population survey. And for for China, I'm using urban household survey, the UHS. So
okay, so it's all urban households.
Yes. So for the US, I restrict the sample to metropolitan areas, so to have a similar notion to the urban areas, because for China, I only have access to the urban households.
Okay. Another question I have is like the higher parts of these profiles. Is it something to do with the hours? Like we have people working for longer hours today recently.
Yes. So there is one data limitation for the China's case, because UHS does not really record hours information. But what we have is, so actually UHS 2002 and 2006, for these 5 years, they do record hours. So what we can see here is, so for US, we actually always have hours information in CPS. The green line is the hours in the US between 2002 and 2006. I grouped these 5 years just to compare the case of China, and I plot the life cycle profile, the age profile, and I do the same thing for China for UHS 2002 and 2006, which I have the hours information. So I cannot really look at the time series, but at least at the cross section, we do not see a huge difference in hours, at least for these 5 years that we have data.
Okay, so we can't see the changes in the hours over time. Basically, that's the data limitations.
Yes, yeah.
Okay, got it.
And that's a good point, and we are gonna abstract from hours in this presentation. And I actually also checked CFPS, which record hours information, but for pretty recent years. We can only have a few recent years since 2012, and I do not observe much changes in hours either. Okay, let me come back to this graph again. So basically the information is for the US, the earnings profiles do not change much in terms of both shapes and levels. But in China, at first, the earnings profiles are increasing and becoming flat. And nowadays, it reaches the peak at a very young age of around 35 years old. And if we plot the estimated peak age and plot the evolution of the golden age in US and in China, and we can see that the golden age in the US is pretty flat at around 45 and 50 years old during the past 30 years, but in China, it's keep declining. So in the late 80s, it's around 55 years old, and nowadays it's only 35 years old. Now we look at the point Nancy already pointed to. So so far, I'm showing the cross-sectional profiles. So a cross-sectional profile plots the average earnings for different age group at a given point of time. So each curve represents a given year or given group of years. A related concept, but different concept, is a life cycle profile, which tracks a given cohort at different ages. So in the left panel here, I just replicate the cross-sectional profiles we already seen for after 2000. In the right panel now, I plot the life cycle profile for various cohorts and track each cohort over their life cycle as the cohort ages. So conceptually, they are different things. But for the case of US, they actually look pretty similar in the data. So this means, so conceptually, when researchers are trying to infer life cycle patterns directly from the cross-sectional patterns, it's not the right concept, but in practice, this is actually pretty good approximation, at least for US. Now, if I do the same thing for China, they basically are utterly different from each other. And notice that this is actually using the same data set, completely the same information, but just the two different ways of plotting the data. And the patterns are absolutely different from each other. So this is what we've seen before. And for the life cycle pattern in China, we see that, first of all, different cohorts have very different life cycle profiles. And both the levels and the slopes are kind of changing over time.
I guess
so
oh, sorry. I was gonna say, like, I think the point that you want to make, which is really interesting, it will probably be made more saliently if you just took out growth, right? That affects everyone the same. Because like, the level shifts up in both figures. That's just growth that affects everyone, which isn't really, and you're focused on something that's like age specific. And maybe we can just visualize that more clearly if you kind of remove the growth.
Yes, that's a good suggestion. But actually, to remove the growth rate, we already need to use the results I'm gonna talk about later. But yes, that's
sorry. Is it necessary? I mean, do we take growth as exogenous, or is really endogenous? The growth is related to the change in the type of human capital, the capability of the cohort. I think their paper may bring us to that point. So it's not just about growth per se, it's really about this group of people. It's different.
Yeah, so you're right. So I had another question, which is, when you, I guess part of the, this fact that the age profiles are different across cohorts is telling us, I mean, feel free to postpone this to the model, but it's telling us that people from different cohorts, they're not very substitutable in the labor market, right? It has something to do with the substitutability across cohorts. Can you get at that more precisely with the data? Like, can you look within the same sectors and see if, that can tell us something more?
Yeah, that's a good point too. I'm gonna comment on the substitutability across cohorts later, but for the results I'm gonna present today, we don't have we don't allow for elasticity of substitution across cohort. Basically, we assume perfect substitutability across cohorts, but I'm gonna be precise about that soon. So the talk is going to have 3 parts. We've already talked about the first part, which is basically a descriptive, several descriptive facts. In particular, we document that the golden age decreased from 55 to 35 years old in China, but is pretty constant at around 45 to 50 years old in the US. And second is that the age-specific earnings grow drastically in China, but almost stagnate in the US. And third, the cross-sectional and life cycle profiles are very different in China, but look pretty much the same in the US. In the second part, we're gonna propose a very simple conceptual framework to understand this cross-sectional or life cycle profiles. And in particular, we're gonna decompose the observations into 3 components. And one, experience effect. We think of the experience effect as the life cycle human capital accumulation. The second, cohort effect. We're gonna think of cohort effect as the cohort specific human capital. So kind of the cohort fixed effect. And the changes in the cohort effect reflects the inter-cohort human capital growth. The last part is the last component is time effect. And we think of time effect as reflecting the human capital prices. So the changes in the time effect reflects the human capital price changes over time. In the last part of the talk, we are going to apply this decomposition framework to revisit several classical questions, including growth accounting and a skill bias technological change. So I'm going to describe the conceptual framework, which is super duper simple, but is actually powerful. So we think of a competitive benchmark in the sense that a wage is simply a product of human capital prices and human capital quantity. Or if we write in logs, so we just write things in additive terms, so that's the math is going to be easier. We use T to denote time and I for an individual. So we can group individuals according to their birth cohort, and they define the average human capital of a given cohort, say C. So basically, the average human capital of cohort C is at some time T is the average of the individual human capital for individuals that was born in year C. And by construction, the residual, so the deviation of individual human capital from their cohort average is has a conditional mean of 0. And hence we can rewrite this wage process as the sum of human capital price, cohort specific human capital, and some residual term. So as I said, this is very simple, but actually powerful, because in many previous research, we tend to ignore either P or H in the wage process. For example, if you interpret the life cycle wage profile as the life cycle human capital accumulation, in that interpretation, we actually abstract from changes in P and simply think of wage as reflecting solely human capital. In the other strands of literature, like the skill biased the skill biased technological change. For example, when we look at the wage premium of the college graduates compared to high school graduates, when we compare the relative wage of college and high school graduates, if you want to interpret that as reflecting the relative price of high skill versus low skill, in that interpretation, we actually abstract from changes in human capital. So these simplifications in the interpretation is actually due to a non-identification I'm going to talk about soon, but I just want to mention that although this framework is pretty simple, it's actually is very informative. So to proceed, we further decompose human capital into two components, including the so-called, so we think of this as cohort effect. S denotes the initial human capital of the cohort when they enter the labor market. And an experience, a component reflects the experience effect. So after they enter the labor market, they start to accumulate experience, and this is reflected in R. So the subscript denote the years of experience, or think of it as ages, and the superscript is the cohort. So at this stage, this is without loss, and we simply rewrite the cohort-specific human capital as the sum of a fixed effect that reflects the human capital when entry, and a second term reflect the human capital accumulation. But in practice, we're gonna restrict the experience effect to be the same across cohort in this assumption. I just want to mention that it does not help identification. This assumption is merely for simplicity and merely because of a data limitation. Because if we really want to get the whole cohort-specific life cycle experience effect, we at least need to observe the whole life cycle for cohorts. But in practice, we only observe very few cohorts for the whole life cycle. So we're gonna make this simplifying assumption. Now with this framework, we can go back to think of what would be a cross-sectional profile. So I use W hat to denote the cross-sectional profile at given time t. So a cross-sectional profile is a collection of average wages for different ages at the given time t. So basically, these are, so for at time t and for a cohort of age k, these two numbers uniquely give the cohort which is t minus k. So this gives us the cross-sectional profile, which is the time effect at t and the cohort effect of t minus k and the experience effect of k years old. Now, if we think of the shape of the cross-sectional profile, let's say we just look at the first order derivative. So the slope of the profile. Because we are looking at a given t, so p of t will disappear in the slope. And the slope of the cross-sectional profile is simply a race between changes in experience effect. So we think of this as return to experience, and changes in cohort effect. So the inter-cohort human capital growth. Under some regularity conditions, say the experience effects are concave, and we only have a unimodal profile, then the golden age is going to happen at the point where return to experience exactly cancels off with the intercohort human capital growth. So think of the two extreme cases. So in the first case, let's say there is simply no intercohort human capital growth. Then the cross-sectional profile we observe simply reflects return to experience. And it's gonna be keep increasing. And hence the golden age will be very old. In the other extreme, let's say there is no return to experience. So the first term is 0. Then the cross-sectional profile simply reflects the minus S dot, so the negative intercohort human capital growth. And intuitively, in this case, the golden age will be very young, because if there is no return to experience and later cohorts are more productive, then the golden age tends to be young. So this suggests that one possibility for what we observed in the first part is that in the US, probably return to experience is relatively large compared to intercohort human capital growth, while in China, intercohort growth is much larger. We can similarly think of the life cycle profile. So a life cycle profile in the bottom part here is tracking a given cohort C at different ages K. So in this case, we are looking at different time period where T corresponds to C plus K. We can similarly think of the slope of the profile. Now we are looking at a given cohort C, so the intercohort changes disappear in the shape, in the slope. So the life cycle profile will reflect two effects: one, return to experience, and second, human capital price changes over time. So now we compare these two profiles. We compare the slopes of these two profiles. If both intercohort growth and price changes are very small, let's say if both of them are 0, then these two slopes are reflecting returns to experience, and these two profiles should look pretty much the same. However, if these two are large, then the two profiles are going to be very different. So just to remind you that in the US, we observed that the cross-sectional profiles are pretty much the same to the life cycle profile, suggesting that this intercohort growth and human capital price changes are small in the US. While these two differs a lot in China, suggesting that at least one of them should be pretty large, different from 0. So this simple conceptual framework provides us a benchmark to think of the potential underlying reasons that produce the pattern we observe in the beginning. So now let's take this simple framework to data. So now we have a model where wages reflects human capital price and cohort effect and return to experience. And we have access to a repeated cross-sectional data set of wages. Notice the perfect collinearity among time, cohort, and experience. We have a non-identification issue. And a common one strategy in the literature is that we need to impose one more restriction. And in particular, we're going to adopt this assumption that there is no experience effect at the end of the working career. So this assumption is actually consistent with all the prominent models of wage dynamics, including human capital, endogenous human capital investment models like Ben-Porres, and on-the-job search theories, as well as job matching with learning. This identification assumption is often attributed to a 1908 paper by Heckman, Lochner, and Taber. And there are a few recent variants. And in particular, this JPE paper by Nancy and the co-authors is actually a state-of-the-art treatment of this non-identification issue and several identifying approaches. So to illustrate how this assumption helps identification, we think of, let's say we assume there is no experience effect from R-1 to R years old. Think of R as retirement. So this is just to illustrate the idea. In the actual algorithm, it's going to be a little bit more sophisticated, but to illustrate the intuition, let's think of this is the assumption. Then if we compare R-1 year old in year T-1 versus the wage of R year old in year T, note that they are the same cohort. So basically we don't have cohort effects. And by assumption, there is no experience effect from R-1 to R. So the difference simply reflects the time effect from T-1 to T. With this time effect, now if we compare wages of A-1 year old in year T-1 versus wages of A year old in year T. So now, again, these are the same cohorts. And now we already identified the time effects. So the difference would be, we would get experience effects between A-1 and A year old by subtracting the difference here with the time effect we already identified. Lastly, if we compare the wages of A year old in year T and A+1 year old in year T, so they are in the same year, so there is no year effect. And we already get experience effect, and hence we can obtain the cohort effects. So this is how intuitively we can achieve identification with the assumption that there is no experience effect in the late in the working career. So actually any normalization for the first order difference would work, but this would be the most plausible one. And actually we could, we have one kind of free parameter in terms of how to specify the flat region here. We just follow the JPE paper by Nancy and co-authors to set the flat region as the last 10 years in their baseline specification. So this is what we would get from the estimation using the identification assumption. So first of all, the experience effect, which reflects the life cycle human capital accumulation. The blue lines are for the US and the red lines are for China. So we find that the experience effects are much larger in US than in China. So this actually complements this paper where they find that experience effects are typically larger than in developed countries than in development countries. And we confirm their finding that by showing in particular two countries, for US and China. Second, the cohort effects reflecting the inter-cohort human capital growth. So in the US, there is some inter-cohort growth for the 1940 cohorts, but afterwards, the growth is pretty small. For China, there is a kind of opposite pattern that for cohorts that were born prior to 1950, we don't observe much intercohort growth, but after that, we observe a huge growth rate. And I think this also, so go back to the Nancy's point in the very beginning. So those cohorts presumably most affected by cultural revolution. And indeed, we find there are almost no intercohort growth here. But after that, the intercohort growth is huge. Lastly, the time effects. So for the US, there is barely any human capital changes. And if anything, it's actually about a 1% decrease per year. But for China, human capital price increases dramatically, about 3.5 times higher as 30 years ago. And we acknowledge there is a few so there is some arbitrariness in the identification. So we also play with a few alternative assumptions in terms of, So although the numbers change a little bit across different specifications, they all reveal the same broad picture that experience effect is much higher in the US than in China. And the cohort effect. Yeah.
Sorry, can I ask a question?
Sure.
Are there like a deeper fundamentals you can link to that will say it's sensible to have this type of a differences? For example, like Nancy's Cultural Revolution cohort is one such example. That you had a wasted cohort that have extremely low human capital, and maybe the other thing will be China being a poorer country. You start with a lower base, so therefore there's a catch up in terms of schoolings or human capital acquisitions, stuff like this. What are the, beyond those, are there other deeper fundamentals you have in mind that will give this kind of differences between the two countries? And should we expect China to eventually converge towards US pictures in your framework?
So for this question, actually, what the approach we take in this project is to do a decomposition without referring to the, say, the institutional differences, and we just think of at the conceptual level how experience, cohort, and time, so human capital, price, contribute to the picture we've seen. This is actually a very good question. We didn't have much to say about that in this project. But for the second part of your question, we're gonna illustrate one potential scenario that China might converge to the US case within our framework. I'm gonna talk about that in the end.
I've been thinking about along the same line. I wonder if you can cut this based on location to see it, because well, basically what we observe, the same variations across different provinces. Would the more advanced provinces begin to approach more like the US pattern?
Yes, that's a good suggestion. So we've looked at this before, but actually the sample size per province is relatively small in UHS. So we do not get a very good, we don't get pretty, we don't find any particular thing that coming out from that analysis. But ideally, I think
what if instead of provinces, you cut them into regions?
Yeah, that's a good suggestion. We could do that. We didn't look at that before, but I could check that. Thanks. Sorry. Okay. Sorry about that. Okay. So now we can apply this framework to think of some classical issues. The first one include we're going to think about growth accounting by taking into account human capital increases. So we're just going to be simple about the aggregate production function by assuming a Cobb-Douglas functional form, and increases in output per worker reflects three parts. So increases in TFP, increases in physical capital per worker, actually physical capital per human capital efficiency, and increases in human capital. So why? So output per worker and K, the physical capital per worker, can be obtained from data. And this H, human capital efficiency per worker, cannot be directly obtained from data, but can be obtained from our decomposition framework by taking the difference of the increase in average wages and changes in human capital. And
can I ask a clarifying question about this formula? Suppose physical capital also has a strong vintage effect. Later vintage are much more productive than earlier ones. Under your current formulation, would you attribute the vintage effect of K? Would you push it into H or not?
Yes, that's a good question. Yes, so one example would be, let's say, only young cohorts can use the latest, let's say, technology, like say computers, something like that. Then in our framework, it is as if the younger cohorts have a higher effective human capital efficiency units. So although fundamentally that's they are using the latest vintage of capital, but we're going to interpret as they have higher efficiency units in human capital. Okay, and this alpha we're going to take from data as the labor share for year T. So with this few elements from data and changes in human capital from our framework, we could have a residual measure for TFP. So
just want to clarify. So literally you want to have alpha to be alpha T, right? And why don't you change alpha also? Why don't you have D alpha times whatever the log K stuff,
yes,
and the minus log H stuff. The change of endowment in levels changing the capital bias technology.
Yes, we actually do have changes in alpha. So if you check the paper, we do have a term that reflects changes in alpha, but here just for illustration purpose, I do not show that in the slides, and mainly because in practice, the term from changes in alpha is very small. So conceptually, the changes in alpha affect the expression, but numerically, they don't affect much.
Yeah, but the purpose I think to do a better accounting to consider bias technology change using CES is much better. And then you can derive a full formula rather than just using alpha T directly.
I see. Yes. So our framework. So one caveat that so the reason we do not use the CES is because our framework does not allow for does not guide us in terms of how to identify the elasticity of substitution between capital and the labor, but I guess probably, yeah, that's actually a good suggestion. Probably we could, let's say, just use some numbers and calibrate to the numbers that used in the literature, probably as an exercise to illustrate, but yes. Okay, and so later on, we're going to have some elasticity substitution between, so along these lines, but we think of the elasticity substitution between different types of labor, but we do not have that for capital and labor. So in this framework, now we can do a decomposition of the contributions to growth in GDP per worker. So the black line is the GDP per worker in both countries. And so the blue lines are from data, the red lines are from data, the physical capital. Blue lines are from our decomposition framework, reflects human capital. So after adjusting for human capital, we actually see that the TFP in the US is actually negative. For China, it's still increasing, but it would be smaller than previous estimates. So for example, so actually our estimates, the growth rates in the TFP, residualized TFP, or residual TFP, coincides with estimates, for example, by Zhu Xiaodong's estimates in terms of the timing of the growth, but the levels are much lower because of we adjust for the human capital. So similar for the US, people have documented TFP slowdown in the US, although they still report almost zero, but still positive estimates. We report a negative estimate here. So this is not inconsistency, just because of the definition of TFP is different. So in our case, TFP, so basically what people normally think of TFP actually include changes in human capital as well. So we're gonna exclude those parts, and this is the residual in our decomposition. Now, if we think of...
May I go back to your previous slides, please?
Yes.
What is your interpretation for the blue line? The human capital contribution to the growth in GDP per capita, per worker, I mean.
So this is the...
Why is it so unimpressive?
Sorry, could you?
Why is the blue line for China, the human capital, the contribution of human capital per capita to the growth in GDP per capita, it looks flat, and that to me is a bit counterintuitive. I thought that. I mean, I thought that if I just looked at academics, I feel that the human capital has gone up a lot.
So,
I mean, the contribution to GDP has gone up a lot.
So
it's very counterintuitive to me.
So, so this is the, so okay. So I guess so from our decomposition, we do identify a huge increase in the inter-cohort human capital growth. I guess that's what we have in mind, but that's not contradictory to the relatively low contribution to GDP, because those increase in the recent cohort is still a small fraction of the whole economy. So the large increase in the most recent cohort constitutes only a small fraction of the whole economy. So that's probably the reason why the contribution is not as large as the inter-cohort human capital growth that we've estimated in a few slides ago.
Xincheng, just to add on, I think the labor share also differ between US and China, right? The alpha T.
Yes. Yeah. But it also differs. Yes.
But which one is bigger?
Actually, I think that's bigger in China, I think.
Labor share
But
is
they're going the opposite
Also-
direction from,
the labor share is smaller in
So-
China.
which will be, wouldn't that be, so that's a statement on data quality, because normally you would think labor abundant country should have a higher labor share. But I believe like they are, your data, you don't use firm level data at all, right? Yours,
No, right. This is all coming from aggregate data, and we only use individual level data to identify the decomposition we talked about before. But in this exercise,
so
we
the
only
labor
use
share comes
aggregate
from
data.
income distribution.
Yes.
National income decomposition. Okay, so if national income
Yeah.
assigns a small share to labor, you assume small share in the production functions, right? That's the
Yes.
assumption.
Yes. That's right. Yeah. That's right.
But
Okay.
there you can correct probably. I mean, probably it's not right. So that's somehow the income distribution, national income distribution, factor share national income distribution for one reason or the other does not correspond to the production function in the
I
economy.
see. Okay.
That may be a
Thanks.
part of the answer to Bernard's question. That
Okay. Yeah. Thanks for helping me out with this question. So now we're gonna try to understand the changes in human capital prices. So in our framework, human capital price simply reflects the marginal product, and the changes would reflect changes in TFP and changes in apart from the labor share, and also changes in the capital intensity. So this is just to help rationalize whether decrease of human capital price in the US makes sense or not. So actually the decrease in human capital price in the US is mostly coming from changes. So increase in capital intensity would decrease human capital price. The blue line reflects the changes in labor share. So after 2000, the labor share declines actually a lot, but the contribution is not that large. We also do a similar decomposition for China, that increase in human capital prices is mostly coming from increase in capital intensity, which increase the marginal product of work of labor. And the other contributions from TFP, but labor share does not affect it much. So the second application we've done is to separately estimate the experience cohort and time effect changes for two skill groups for college and high school. So within each education group, we still observe that US has a higher return to experience than in China. But we also see that higher education group tend to have a higher return to experience. For the cohort effect, we see that most of the cohort effect is coming from college graduates in China. And in the US, it's actually a divergent pattern for the cohort effect. This is kind of, so this reflects the fanning out effect in the US wage distribution. People typically document that the wage of the high skill group is increasing while the wage of low skill group is actually declining. In terms of time effect, there are not much difference within the group between the two countries, although the levels differs a little bit. And we can take this as inputs to understand the changes in college premium. as I mentioned at the very beginning, that changes college premium could be, for example, the rising college premium in the US could come from rising human capital prices, which is the typical interpretation in the literature, or relative, so the increase in relative human capital of the college graduates compared to high school graduates. Actually, using our estimates, we find that the college premium is mostly driven by human capital quantity increases. In fact, the relative human capital price is declining for the US. For China, both relative quantity and relative price increases, and price contributes to about 2/3. A natural question is whether this declining contribution of declining relative human capital price is in contradiction to the skill bias technological changes. And we can follow the framework, a very simple framework to understand skill bias technological change, where we have elasticity of substitution between high-skilled workers and low-skilled workers, and each of them has their specific skill-specific technological changes. And we can decompose the relative.
I just want to let you know, you have 3 more minutes.
Oh, okay, thank you. So we can just decompose these relative human capital price changes into several factors, and this one is reflecting the skill bias technological change. In fact, this is not in contradiction to the skill bias technological change, because the declining in human capital prices is actually mainly coming from the increases in the relative human capital. And after we accounting for that, we still observe a skill bias technological change in the US and actually in both countries. And it's even more skill bias in China. The last thing we look at is a hypothetical scenario that we assume China starts to slow down in terms of its inter-cohort human capital growth and human capital price growth. In particular, we assume an average rate of decrease in both rates to the US level, which is almost 0 in 30 years. And this is what happened in this hypothetical scenario. So here we actually hold the experience effect as constant as right now in the estimate. And in this hypothetical scenario, we just let the cohort and time effect to slow down. And we can see that, so first of all, the increase between two curves are beginning to shrink, reflecting the slowdown in the human capital price increases. And also the golden age starts to decline. So this is because over time, when the intercohort growth start to slow down, experience effect is gonna gradually dominate the intercohort human capital growth, and hence we observe an older and older golden age. And this scenario seems to be pretty plausible for what happened in Korea since their late 90s, where they just ended the fastest growth and start to slow down. So just to conclude, we document some stark differences in the age earnings profiles, and I'm gonna skip these detailed points. And it's actually a golden age of the intercohort productivity growth in China. And we can apply this decomposition to revisit a few questions and change the conclusions we've reached before in some cases. Okay, that's all for my presentation.
Thank you so much. Thank you for stopping right on time. So we have another break before our last talk. As usual, we're going to keep the room open for everyone to keep talking, and then we will be back in 14 minutes.